Hey guys, welcome back to Houdini Houdono, the simulation edition. This is a 10-part mini tutorial series where I'm going to show you the most cost-effective simulation setups. And by that I mean setups that look pretty cool for very little effort. Then we can feel more encouraged as we learn the simulation tools in Houdini. So in this video I'm going to show you what you see on screen now. It's a disintegration effect. Okay. So I realized in the last video I didn't give a breakdown of how I'm going to approach the setup before I start going into the details. So in this video I'm going to do it slightly differently. I'm going to show you a run through an existing setup, explain the theory behind it, and then we'll go through how to create a setup. Okay, so let's get started. Okay, so I know what you saw in the render earlier, but this is the Playblast version or the flipbook version of what we're going to create. Essentially, we are going to have a source model, and this model I downloaded from 3dscans.com. You can use any model to follow along with this tutorial. Essentially, we want to have an object to clip the original source geometry so that we achieve this kind of cutting away effect. And from the transition of the cut, we are going to emit some particles. Onto these particles, we are going to copy some geometry that makes it look like it's from the source model, right? To give the illusion that it's disintegrating. Lastly, we're going to control the particles such that over time they get smaller, right? So they become dust particles. So let's go through step by step how to achieve this. So in this setup node, it can get a little messy if you see all the other objects in your scene. So just a quick tip, you can click here and go to hide other objects. So you will only concentrate on what is in this particular geometry context. Okay, so I brought in this model from 3dscans.com. It's quite high resolution and also it's about 1000 units wide. So I ran a poly reduced and I cached it out. This is the poly count now, and I did a match size node to ensure that it is fit to scale on a 1x1 world unit. And I also choose the justify y to be on minimum value such that it will force the model to sit on the ground like this. This is a very good way to ensure that our model is sitting on the ground. And next we have to set up a clipping geometry like I mentioned earlier. So this is a sphere. I drop down a transform node to animate it from the top left corner of the screen to the center over here. And with the model ghosted like this, you can see how the geometry is going to be clipped. And on top of that, I added a mountain function to generate some noise so that the Boolean looks a little bit more organic like this as it gets clipped away. And so I have two Boolean functions over here. They are exactly the same except I want different outputs from them. On the left, I want the output of the seam of the transition, right? So you can see here that I chose seam. And from this, I dropped down a pop net, added some wind like this. And onto these particles, I prepared a simple geometry like this. Got a box, subdivided it, added some noise, subdivided it further, and copied onto the particles like this. So essentially what we get is this effect over here. From the camera, it looks like this. Right. Finally, over on the right side, I have my Boolean node. It's the same Boolean node, except that this time instead of the seam, I chose subtract. Essentially what it does is getting one of the geometries to subtract the other geometry, right? Resulting in a geometry like this. And when we merge these two outputs together, in this case, I dropped two out nodes and object merge them in the object context, then we can see we achieve the illusion of it disintegrating. Okay, so this is the general approach for the setup. I'm going to recreate this setup so you can see step by step and how I adjust the parameters for each node. Okay, let's get to a new file. Okay, so we are now in an empty scene. I'm going to create a geometry node and I'm going to call this setup and just going to hide it because I don't want to render this setup. Okay. And from here, I'm going to drop down a file node and pick up the object that I downloaded from 3dscans.com. And I'm going to drop down a poly reduce node and just keep 5% of this density of a geometry. Let it compute. Okay, when it's done, drop down a file cache and choose current frame. I'm on frame 1 now and just click on save to disk. I'm just going to name this as reduced. Save to disk, and I'm going to drop down a separate file node to bring in this reduced geometry. So I have my geometry here, and now it's time to drop down a match size node, which automatically brings my geometry to the center of the world. If I choose my justify y to be minimum, it automatically sets it to the ground. This is 600 units, almost 1000 units wide, so I'm just going to check this fit to scale, uniform scale. and I'm working at a more comfortable 1 by 1. So now I'm going to prepare the sphere that intersects this geometry. I'm going to drop down a sphere, set it to polygons, and give it a frequency of 32. And I'm just going to change my project timeline settings to 100 because that's all I need. And then I'm going to check the real-time toggle. I'm just going to drop down now the Boolean function, and we can see, no, we cannot see. So I'm going to try to move this sphere away by dropping down a transform node. Hover over the viewport, press enter, and we can manipulate this sphere. I'm going to just template this match size to be able to see what I'm doing. So let's see the Boolean output. This is not the output that we want. We want the seam over here. So let's choose seam. And I actually want the polygonal plane that comes out of this. So I'll highlight the Boolean node and press escape when I hover over the viewport to temporarily remove the UI of the Boolean. And you can see that the output generates a seam of the transition like this. I'm going to uncheck use only open curves so that if I press W on my viewport, you can see that it actually outputs an entire primitive like this, a surface if you will, so that when I drop down a pop net, it will release particles from the surface instead of from the points. So let's put that to the test. Drop down pop net, highlight the pop net, and we can see that it generates points on the surface. Next, I'm going to make the disintegration effect towards the negative x-axis and add some noise. So I'm going to jump inside, drop down pop wind, wire it after the source. Just make sure you drop it between the line. Give it a noise amplitude under the noise tab of 2, and under wind velocity, give it on the x-axis -2, and then we can see this happen. Okay, there's an issue here. It's going into the ground, and that's not what we want. So let me quickly wire a ground plane node and select the first one, select the second one, alt drag from one of them will give you a merge node, and we can put it into the output context like this. So let's go back to the first frame and play back. Then we can see that it doesn't get into the flow anymore. On the pop net, by default, there's a star over here, an asterisk, which picks up every object that you drop into the pop net. And in this case, the two valid objects are the ground plane and the pop object. And this will cause an undesired result when we copy some geometry onto the points, because it will start to register the ground plane's points as part of the points to copy points onto, right? So we don't want that. We only want the pop object. So let me copy this name and get out here, and instead of the asterisk, which is a wildcard to pick up every object in the .NET, I'm going to paste I only want pop object. Okay, so now I only get my particles, right? The core of this effect is basically almost done. We've got the particles, and then let's have another Boolean function. Just alt drag from this guy. It automatically creates a copy of it with the correct inputs. And I'm going to change this to the subtract. And I don't want the sculpture subtracted from the sphere. I want the sphere subtracted from the sculpture. So I'm going to change this function here from B to A. There we have it. Now I want to address the fact that this cutting here is a little bit smooth and not very organic. So I will drop down a mountain node onto my sphere. And let me just check out the Boolean function. We have generated quite a fair bit of resolution on our sphere here, but it doesn't seem to match up so well. So I'm going to change this to 64 just to double it. And our mountain function, it's fairly okay, but I think it's a little bit big and a bit too volatile. So I'm just going to reduce its magnitude by quite a bit. Just this will do. And I'm going to start to run my animation. So the last frame, I'm going to alt click on frame 100, the translation and the uniform scale on my transform node. And on the first frame, I'm going to highlight my sculpture and size it down by half, press enter, and try to move this to the top left of my sculpture. Something like this. Just tumble your camera around a little bit just to make sure that it's not intersecting. And remember to set a key, alt click here and alt click over here. So a key has been set on these two. And on the last frame, I want to just ensure that it encompasses the whole model. Since we centered it to the world, I believe I can just center this like this. So you can see it grows and intersects the geometry like this, resulting in a Boolean function that looks like this. So let's have a preview. It goes like this. Okay, so on this Boolean node, we should get the exact same animation because it's sourcing the same two source geometries over here. One is the seam and one is the geometry. At this point, we can, in order to feel a bit more encouraged, we can select both nodes and Alt drag as a preview, then we can see, hey, we're almost done with our disintegration effect. Oh no, the reason why it's so slow is just because the Boolean function is slow. Okay, just note that the Boolean function, when it's operating on high resolution geometry, is not the fastest thing to compute, so you cannot really see this in real time, so I recommend that we cache it. So drop down a file cache node over here and just call this the sculpture, and I'll run this cache, save to disk, and after the cache is done, drop down a separate file node to bring in the sculpture, which is over here. Okay, so that's done, and as you can see now that it's fairly fast to update like this. So now we can preview our little simulation. Oh, and there's a crash. So now that the Boolean is cached, it plays back very fast, so that's good. And let's have a look at our popnet. But I think we can also afford to cache it, so I'm gonna duplicate my cache nodes from the right side and rename this as particles. Also rename this as particles, and just run the cache on these particles over here. Save to disk. So once that is done, we can just bring in the cache. This is our cache, and now we can attempt to color the particles by dropping down an attribute randomize. By default, it randomizes based on per point, so we get some colors. Just make sure that the colors are stable. The point ID isn't changing, so these colors are stable, which we don't get any flickering when we use this color attribute to shade, and that is good. Next, we're gonna drop down a box to attempt to copy this box onto all the particles. So let me just make a copy to points and have a look at this, right? So this is the default size and it is not good. So let's make some adjustments. We may be tempted to drop down a transform on the box to make it smaller, but I think we can make use of Houdini's attributes to control this, to control the size of each particle. Right? So drop down a point wrangle. So I'm going to write 3 lines of code over here that will help us to control the size of each instance of a particle. So the first one, it's the idea that we need to write it to an attribute called p-scale. So to write an attribute, drop down the add symbol, and we can equate p-scale to 0.1 for example, and you can see that it has gotten way smaller. So instead of writing a strict value over here, I'm going to create a UI. So I'm going to type CHF, which stands for channel float, and I'm just going to type p-scale multiplier and press this button here, and then we get a slider, which we can slide the size. So that's a good start. I'm going to set it to 0.1 for now. And next, like I mentioned earlier in this video, I want to ensure that the particles over time will get smaller. What is convenient is that this popnet automatically outputs the age attribute. If we middle mouse on the node, we see this age attribute over here, and we can make use of that. Let me type add age multiply by this p-scale. So we kind of get the effect, except that it's reversed. You can see it starts small and it gets bigger over time, and it gets disproportionately big. That's not what we want. This is because the age attribute is written in seconds, and we have about 4 seconds here. So you can essentially see that at the start of this, it's 0 seconds, 1 second, 2 seconds, and 4 seconds, which is 4 units over here. We want to range this age down a little bit, and that is using the fit function. So I'm going to store this information into a local variable instead. So let's make a float local variable called fit age equals to fit. I want to fit my age attribute from 0 to 4 seconds to 0 to 1 instead. And in that case, I'm not going to directly access the age attribute, but my local variable called fit age. So with that, not too much has changed other than I fit it to 0 to 1 instead. So if I want to flip it around, I can use a ramp to do this. So the ramp function only operates from 0 to 1, so it's a good thing that we squeeze the range of our age down to 0 to 1. So let's create another float variable called ramp fit age. This time I'll use a ramp function. The ramp function takes in 2 inputs. The first one being the name of the UI, so I'm just going to call it the same. And the next would be the value that we want to manipulate, which is fit age, and then I can close this function. Remember to click on this button here to generate your UI, and here you can see that now I can control my particles to go from, instead of from small to big, I can make it go from big to small like this, just by inversing this ramp over here. So you can see it goes from big to small, except that I forgot to change this to ramp fit edge. So it goes from big to small over time. So with these two handles selected, I'm going to right click on it, set interpolation to B-spline, and I can make it start quite big and very quickly become small, right? So this is where I can control the size of my particles in a non-linear way using a ramp. So you can start big and become small. So you can see it looks kind of cool now. So let's ensure that we dial down the size of the p-scale multiplier so that we don't get too many intersections. There will be motion blur, so we can get away with some of these. And when we are done, let's now adjust the look of this box, right? It looks a little bit boxy. So we want to try to mimic any kind of geometry that may be displaced from this original sculpture in this fashion here. So I think what we can do is to drop down subdivide and choose the bilinear operation here to just get some divisions without collapsing the geometry. And then we'll drop down a mountain just to give it some variation like this. And then I'll drop down another subdivide, and this time use the default Houdini Catmull Cluck over here, and perhaps drop down another mountain just to give it some noise again. And if we copy this geometry onto the points, we can see that it looks quite organic. And you can see that they are generally oriented the same way. This is because it will by default inherit the velocity attribute to try to orient the instances of the source geometry. So what we have to do now is to drop down a randomize orient attribute. Attribute randomize. And the attribute that we want to randomize is called orient. It's a 4-dimension attribute. And I'm just going to wire this in, and you can see that they are now randomized. It's more natural looking this way. And so now we can drop down our two output nodes. One of it we'll call out particles, and the other we will call it out sculpture. I'm going to highlight these two nodes, jump outside, drop down two geonodes, one of which we'll call particles, the other we'll call it sculpture. And in the particles node, we'll drop down an object merge, go to the setup, pick the particles. I'll copy this object merge and paste it into the sculpture geometry and choose out sculpture. So there we have it, disintegration effect. Some things that we might want to consider is, you can see that it's releasing particles on every frame this way, and it's not very organic. So what we can do is to ensure that on our popnet we increase the substeps, right? So the substeps over here is 1. So every frame on every frame wherever there is the source, the emission geometry, it will emit one set of this. And in order to close these gaps, what we can do is to choose, say, 3 here, force it to be 3 substeps, and I think it will look a little bit better. However, the simulation goes much slower. Another way to alleviate this evenness is to go to the source over here, and on seed, I'm just going to type $FF to randomize the scattering of the points on the surfaces each time. And also the jitter birth time, choose negative, and interpolate source, I'm going to choose back. And because I have introduced 3 substeps, I have essentially increased the number of particles by 3 times. I'm just going to divide this by 3, and that will result in a value of 1006. I'm just going to round that to 1005, and once again run my simulation. You can see now it's much more organic like this. So let me just cache this. Okay, so that cache is done, and you can see it looks a little bit more organic now. Let's look at when we copy the points. I'll just check pack and instance so that it's a little bit more memory efficient. And you can see now it all works very well. And we can preview. Now that our Boolean sculpture is cached, our particles are cached, we should see that this plays back quite well. You can see we effectively solved the stepping over here. And also the next thing we can improve on is perhaps the way this cuts the geometry, but I think it's fine. All these newly introduced particles over here will be motion blurred, so we wouldn't be able to see this seam so well. And I think Because the cache is prior to the adjustment over here, we are still free to adjust the P scale here. We want to get it a little bit bigger at the start and let it fall off a little bit. Oh, maybe like this. That looks kind of cool. Okay, so at this point the effect is done. I hope you enjoyed the tutorial. I usually set up my scene in Redshift. I'm not sure if this applies to you. I'm not sure about everyone's access to Redshift. So if you do want to see how I do a render setup to achieve the result that you saw at the front, please let me know in the comments, then I can include the rendering part of the tutorial into the next tutorials. If not, I think I can stop here and I'll see you next Friday evening. So I'm gonna upload an episode like this every Friday evening. So this is a 10-part tutorial series that I've planned. If you want this file, I'm just gonna drop down some annotations of this file. If you would like to have this file, you can hop over to Instagram. My Instagram handle is at Ronald_Fong, and you can just DM me. I can send you the file or just drop you a link. Alright, thanks and have fun learning simulation in Houdini, and I'll see you next week. Bye.